monomial by a polynomial. So remember, monomial is one term. Polynomial is generally multiple terms. We are going to distribute in order to do that. So something that you're going to need to remember is the product rule. X to the A times X to the B is equal to, what do I do with those exponents? Add, subtract, multiply, or divide? Add. So X to the A plus B. From the test that I've graded already, properties of exponents were not horrible, that part, but for some reason the combining like terms was not great. So we're going to talk about that again today as well. So we're going to distribute. I'm going to multiply x times x. Remember, both of these x's have an exponent of 1. So when I multiply x times x, what do I get? X to the what? Second, 1 plus 1. Then I'm going to multiply x times 4. X times 4 is just 4x. So basic example, but basically what we're doing today, just going to add in some more terms, add in some more variables and exponents. Okay? So we're going to do the same thing for number 2. We're going to distribute. So you're going to multiply 5 times 3, which is 15. And then m to the third times m squared would be m to the what? Fifth. You add the exponents. That's the product rule. Okay, then 5, and there's a negative 1 in front of there technically because it's a minus. So 5 times negative 1 is negative 5. And then what is m to the third times m? M to the fourth. Perfect. And then last but not least, 5 times negative 7 is negative 35. And then I don't have anything to multiply the m to the third with, so I'll just bring it along. Now, what a lot of you guys forgot on your test is that you can only combine things that have the same exponents. So this can't be simplified anymore. Okay, we want our answers to be largest exponent to smallest, so 5, 4, 3, so that's good. But you can only combine them if they have the same exponents. And a lot of people make that mistake. Okay, let's look at number 4, introducing with multiple variable. So same thing. You're going to multiply, distribute. I have 2 terms on the inside here, so I'm multiplying that by 2 separate things. So negative 7 times 9 is negative 63. What is c to the second times c to the third?
C to the fourth.
Perfect. And then what is d squared times d squared?
D to the fourth.
Perfect. So there's my first term. That's multiplying the thing in front of the parentheses with the first term. Remember, terms are separated by addition and subtraction. Then we're going to do negative 7 times negative 4, which turns into a positive 28. What is c to the third times c?
C to the fourth.
C to the fourth. And then what is d to the second times d to the fifth?
A to the seventh.
Perfect. Those are not like terms. They have the same variables, c and d, but those variables don't have the same exponents, so you cannot combine them. So you just leave it. Okay? So now we're going to do a couple examples where there actually are like terms to combine. So let's look at number 5. Negative 2x times 3x. So we're going to distribute first. Then we'll look to see if there's anything to combine. Negative 2 times 3 is negative 6. What is x times x? X to the second. Then we're going to have negative 2 times negative 4, which is positive 8. And then I have nothing to multiply the x by, so I'll just bring it along. And then last but not least, we have plus 7x.
So you can combine 8 and 7 now, right?
Correct. So our answers need to be in standard form. So you want to go largest exponent to smallest. So my largest exponent is the x squared. Nothing else combines with that, so I'm going to bring that down first. Then you'll look to see, okay, my next largest exponent is 1. I have 2 terms like that. So 8 plus 7 is going to give us 15x. And that's our answer. So not really anything new. We're just now going to be distributing with numbers out front, variables out front instead of just numbers. Okay? So let's do the same thing with number 6, distribute. I have 3 terms to distribute here. So after I distribute, I should have 3 separate terms. -2, I have nothing to multiply that with in the first term, so I'll just bring it down. What is r times r to the third? Perfect. Then you should have -2 times -6 is +12. R times r to the second? Yes, r to the third. Perfect. Then you're going to have -2 times 6, which is -12, and you'll attach the r because there's nothing to multiply that way. Then I'm going to bring down the plus 4r to the third because nothing is being distributed, multiplied, anything with that right now. But I have another set of parentheses, which means I have another thing to distribute here. What am I distributing? Okay, this was something that a lot of people forgot on their test. So distribute -1. -1 times 5r to the fourth is -5r to the fourth. And then -1 times 10r is -10r. So we're going to combine like terms, and we're going to make sure our answers are in standard form. What is my largest exponent that I have?
R to the negative. Sorry, R to the fourth.
Yeah, r to the fourth. And I have 2 of those terms, so I'm going to combine those. -2 minus 5 is going to be -7 r to the fourth. Remember, when you're combining like terms, do not change the exponents. So now our next largest exponent is 3. So what's 12 plus 4? 16 r to the third. And then -12 minus 10. -22r. Those are not combinable. They don't have the same exponents. It's in standard form because the exponents are 4, 3, and then 1, so it's decreasing. So we're done. So we do have an application problem for this. So I want to take a second and I just want to talk about area really quick. So area of a rectangle. Let's say that this is 5 and this is 3. If I wanted to find the area of this rectangle, what would it be? 15. You multiply the length times the width. Okay, so the area here is 15. So let's say I have a small rectangle on the inside. And let's say that this area is 3. Okay, so I'm just going to tell you that that area is 3. Meaning like one of the sides could be 1, the other one could be 3. Okay? If I want to find the area of the shaded region, so inside of the large rectangle, but outside of the small rectangle, so I want to find that area, what would I do?
Then you subtract 15 from 3.
Yeah.
Or 3 from 15.
Yeah, exactly. You're going to take the total area, which is 15, and you're going to subtract the area of the small one. So 15 minus 3. So what would be that shaded region? Okay, we're basically going to do that exact same thing. It's just we're going to have expressions instead of numbers. Okay, so how we're going to do the shaded region part is we're going to take the area of the large rectangle. So I'm going to write this out. If you don't want to, that's fine. But area of large rectangle, and you're going to subtract the area of the small rectangle. You're just going to get an expression when you do this. Telling you right now, there's going to be one like this on your test. And we're going to have a test or a quiz, whatever you want to call it, pretty quickly because we only have 2 sections to talk about. So I would say maybe by the end of next week. 2 sections. So area of the large rectangle means we're going to multiply the 2 side lengths of the large rectangle. So I'm going to multiply 8x minus 1 and 6x. Now, usually how we write that is we'll put the monomial, which is the one term, in front of parentheses. So I'm going to do 6x out front, and then I'll put the 8x minus 1 in parentheses because I'm multiplying the 6x times the entire thing. not just the 8x. Multiply by that whole thing. Then we're going to do minus. How would I write out the area of the small rectangle?
2x and then 5x plus 3 in parentheses.
Perfect. And so the last thing you would do here is distribute and combine like terms. Guys. Okay, so distribute 6x plus, times 8x is 48 what?
X
Squared. 1 plus 1 is 2. Those are the exponents there. 6x times negative 1 is negative 6x. So technically this right here is the area of the large rectangle. Now we don't know what x is, but we could, if we were told what x is, we could plug it in and find the area easily. Okay, then we're going to distribute negative 2 to both of these terms. Negative 2x, sorry. Negative 2 times 5 is negative 10. And then what is x times x? X squared. And then negative 2 times 3 is negative 6. I have nothing to multiply the x with, so I'll just attach it. And then the last thing you do here is combine like terms. Yes. If I have 48x squareds and I take away 10 of them, how many do I have?
38.
38x squareds.
Wait, couldn't 6 and 9? Oh, never mind.
Okay, then we're going to combine the x's here. This is, people see the same number and want to say the answer is 0. But this is like saying you're borrowing $6 from a friend, and then the next day you borrow 6 more. How much do you owe your friend? $12. So this is minus 12x. Okay, it does not equal 0. One of those would have to be a plus in order for those to cancel. So just be careful with that. Okay? So that's going to be our final answer. If we knew what x was, let's say x is 5, I could plug in 5 there, and that would give me the area of that region. Okay? So the last piece of this, and I think the easiest part of this, is the reverse of what we're doing, which is the quotient. Okay, so when we divide a polynomial by a monomial, we use the quotient rule, which is x to the a over x to the b. What do I do with those exponents? Subtract. So when you're multiplying two things with the same base, you add. When you're dividing two things with the same base, you subtract. Okay, so what we're going to do is we're going to take each term in the numerator and we're going to divide it by the denominator. So let's talk about a term again. Terms are separated by addition and subtraction. Okay, so I have two terms here. I'm going to take both of these terms and divide by the bottom. So 8n squared divided by 4n. So the first term divided by the bottom. Then I have a minus in the middle, so I'll put a minus here. And then I'll do this second term, 36n divided by 4n. And you'll simplify those two things separately. So you're just dividing each thing on top by the bottom.
Once you subtract that.
So yeah, we'll have 8 divided by 4. You don't subtract the numbers in front, guys. This is still division. It's just the exponent rules say we subtract exponents. So 8 divided by 4 is 2. If I have two n's and I'm dividing out 1, how many do I have? 1. If you want to put an exponent of 1, you can, but it's not necessary. Okay, and then we're going to have minus. What is 36 over 4? 9. And then here's where you got to be careful, where everybody messes up. I have 1 n, and I divide out 1 n. How many n's do I have left? 0 n's. So I am not going to put any n's. So here's the thing. If you want to write this as negative 9n to the 0, because 1 minus 1 is in fact 0, that's fine. But then you have to simplify that. Okay, you have to remember anything to the 0 power is 1, so this is really negative 9 times 1, which is negative 9. Okay, I like to think about it as if you have the same number on top and bottom, they cancel. But if you want to write it as n to the 0 and simplify it, that's up to you. Okay, that is a property of exponents. That is why there's no n's there. Okay, so however you would like to do it is fine. Okay, I'm going to do 2 more, 10 and 11, and then I'll let you know what you're working on. So how many terms do I have on top on number 10? 3, which means I'm going to separate this out into 3 fractions. I'm going to have 18x to the third over 3x. Then minus 21x squared over 3x. Then plus 3x over 3x. So you take each of those things on top and you divide by the bottom. 18 divided by 3?
6.
6. If I have 3 x's and I divide 1 out, x squared, perfect. Minus 21 divided by 3?
7.
7. I have 2 x's, I divide 1 out. 1x plus 3 divided by 3?
1.
1. This may not be necessary if we have x's left, but if we don't, then this is necessary. If I have 1x and I divide 1x out, no x's. So I'm going to just cross them out. I'm not going to write any x's there. However, if you would like to write it as x to the 0 and then simplify, you still should get this as your answer. Okay? However, I need to make this very clear to you guys. Okay? However many terms you have on top is how many terms you should end up with. Okay? You should never have like 3 terms on top and you end up with like 2 terms. Okay? You're missing something. Usually it's the plus 1 if the last one divides out. So however many terms on top, when you divide it out, that should be how many terms you end up with. Okay, so the only difference between 10 and 11 is just that we have multiple variables here, but we're still going to treat it the same way. I have 2 terms on top, so I'll have 2 separate fractions. 14x to the 6th, y to the 3rd, over negative 7x to the 4th, y. And then minus 49x to the 5th, y to the 9th, over negative 7x to the 4th, y. I have 2 separate fractions. That means that I should have 2 terms when I'm done. One of those terms might just be 1 or might just be a number, but you still should have 2 terms. So 14 divided by negative 7 is negative 2. If I have 6 x's and I divide out 4, I should have 2 left. If I have 3 y's and I divide out 1, I should have 2 y's left. So there's my first term. Negative divided by a negative is going to be a positive. 49 divided by 7 is 7. If I have 5 x's and I divide out 4, I have 1 x left. 9 y's divide out 1, I have 8 y's left. Those are not like terms. Do not combine them. Okay?